Hello, and welcome to another episode of Risky Business. So, last time we were looking at this PWM stuff here and reviewing so let me see here. There was something where we were thinking about a 16 megahertz clock speed, I think. But maybe not. I'm not seeing it. I think we got that from the documentation. Because we want to know how long a cycle is taking. So let me see here. So yeah, it says in the documentation here, it doesn't look like this is the thing that can be fed with multiple clock sources. It just uses this counter, the count register. And it says something in here about assuming a 16 megahertz clock. But is that going to be based on the speed we're running at? Oh, and let me not forget to do that. Okay, so that's a little bit late, but close enough. So is it going off the speed of the processor, or is it something else? So there's the external 16 megahertz crystal oscillator, which is what I'm thinking it's probably using. So I want to know let me see here. It did say it was the input bus, so I'm wondering if there's documentation on that. I suppose we could test the speed it's running at. So if we use PWM Interrupts, so I'm thinking if we use PWM Interrupts, it looks like we can set it to interrupt based on the comparators. So here, I want to test this. Let's make a separate program. Hello, Deathamageddon. Thank you for tuning in. So let's just make a test directory. Snail. Snail cannon? Or a different snail? I will call you Snail. Okay, yeah, I remember you. Okay, so I'm going to copy that stuff into the test directory. Alright, now we're going to change up this program. So we're not going to be printing these messages anymore. I don't need this. Okay, so here we're setting up the 16 megahertz crystal to run off that. So that's a good starting point. Yeah, we want to do all that. That's good. Oh yeah, I set up a secondary webcam, so you can now see my SiFive 1. So this right here, I know it's pretty dark down there, but this is the SiFive 1. Here, if I try to flash some light on it, that's just from my phone. But there you can kind of see the board a little bit better. My phone's almost dead too. Okay, so we're going to do this stuff, but we're going to get rid of this stuff. I guess technically you could if you had a I think this is micro USB that this phone uses, so if you had like micro USB to micro USB and you set up like an app on the phone to talk to the SiFive 1, you probably could do that actually, because you can communicate over the USB cable using the UART. So I think that would actually potentially work. As long as the app on the phone is set up to properly talk to it. So I'm gonna leave these the same. Although instead of driving the LEDs, I just want to do interrupts. So, and let's not mess with the LEDs. Let's see what we can get rid of. So I think if we just get rid of these, and we're going to change this line. I'll just mark it to do. And I think I'm just going to comment this stuff out for now. Don't need this stuff. And we're not going to check for user input. Okay, so what we've set up now is just something to do like the bare minimum stuff. For PWM. Actually, that comment's pretty useful. Just going to reformat this a teeny bit. Alright, there, now we've got it formatted a little bit better. So basically what I want to do is print when it, like, I want to print the timing of a cycle. Okay, so I think we want to turn on well, I just want to see a full cycle for now, so I'll leave PWM 0 compare off, but I'll turn on the PWM sticky bit. Okay, so I want to turn on enable always, sticky, and I believe that's it for now. I'm going to take a wild guess here and assume that this should be PWM config sticky. We also don't really need these parentheses. And then how do we set up the interrupts? We must need to register, like set up the table of interrupts and do that stuff, right? Okay, so is that going to be a local interrupt or a global interrupt, though? I'd imagine it would be local. So I don't think this document is what we want to be looking at for interrupts. Okay, here we go. So let's see. Interrupt number 40 is what I want, I believe. So here, let's take a look at some of those other demos. I suppose we should figure out where those interrupts are going to be defined. let's check platform.h. Okay, here are interrupt numbers. So there's the one I'm looking for. Now let's go back to the demos. And compare those. So maybe it is global, because it would be part of the PLIC interrupts, right? Yeah, so I want to do the PLIC enable interrupt stuff, basically. So that means I'm going to need to use the PLIC driver. Okay, so we need this. I'll move that down there. I'll structure it the same way that they did in the other one. So I think that looks good. Now we're going to need to include the PLIC driver. And you do that like this. Now we need to do the PLIC init. Let's just copy that code. Alright, and then of course I need the global structure for that. Let me just check my phone quick.
Oh, yeah.
All right. Next, we need to register our interrupts. So we're going to want the interrupt function pointer. I suppose I'll throw the type def up here. And then let's make our table for our global interrupts. Which you do like that. Okay, and then we need to actually set up our table. So basically it's just going to be like this. Looks like they registered the PWM as well. So that's going to go down here. And then I want the PWM 0 handler. Let's just double check. So it should be int PWM 0 base. They named it differently. Good thing we checked. And we don't really need the offset considering we just want comparator 0, so I'm just going to remove that. Wait, I'm in the wrong code base here. Do that here. There we go. And then we want to make the actual handler for it. So let's just take a look at theirs. So I don't think we need to rearm the timer like they do here because we're setting it to enable always instead of one shot. So it should just keep cycling. without us doing anything. So I think we're just going to say first of all, let's just confirm that this works. But then I think we do need to clear the PWM interrupts. Or no, we don't want to mess with it. Yeah, I think this is what I want. And then it should just spam PWM interrupts every time it cycles. And then we're going to change it so that it, instead of spamming PWM interrupt, we'll actually have it print timings so that we can see how fast it's running. So let's see, do we have everything set up the way we want it? Oh, I'm gonna need to do enable interrupt too. Let's see, where should we do that? I suppose we should do that down here. So I guess I'll just put it right here. Or wait, that's going to be PLIC enable interrupts. We pass it the structure, and we pass it to the interrupt we want to enable. So that's going to be int PWM0 base. And then we're going to enable the global PLIC interrupts with the set CSR call. That takes MIE, MIP, MEIP. And that's enable interrupts pending. And then I guess we want to enable all interrupts too. Let's do that. All right. Now I think we can do this fancy little wait for interrupt call here. We learned about that the other day. And I don't know if it's a no-op on the SiFive one or not, but it can't hurt. So I think this gives us everything we need to do a basic thing to spam PWM interrupt when there is a PWM interrupt. If I've done everything correct. This is the first time on the series we've actually like written any code. So we'll see how it goes. But I mean, it wasn't really writing code, it was basically just copy pasta. But we're gonna see how it goes. So I guess I want to be here. And we want to set the program to test. And we've got some warnings and some errors. Okay, so we're missing some includes basically. So first one is set CSR. Where is that defined? Here, let me open up. Okay. So we want to know where set CSR is first of all. So I'm including the PLIC driver and platform.h. It's probably in encoding.h. In fact, I'm pretty sure I remember it being in encoding.h, so let's just throw that in there right now. And it looks like that's built. I guess that's all we needed. Now, we're going to try to upload it to the board. Here, let me just check if its make upload is the right. Yes. Okay, it says it successfully uploaded it. Let's connect to it with a screen. And we're going to hit the, oh, screen terminated. So, we get a flashing light for like a second. And then it goes off and screen terminates, which means the program must terminate. Very interesting. I wonder if we set the compare 0 register to something. I think that was the value we were using with the LED stuff. You know, I should probably make clean too. So did that not upload it? I think that failed to upload. This is complaining. Oh, when I didn't make clean, I think I cleaned the build of the SDK. That would explain why my tools are missing. Well, I guess we need to rebuild the SDK. What's the proper way to clean the... Let me go to the SiFive Forums. Software clean is what I wanted. So let me see here. So we're going to need to do make tools again. And this is going to take a while, so I might need to end the episode, and then we'll continue after it's rebuilt. So, it'll probably be like, I don't know, 30 minutes, I'd guess. I'll put on some music while this runs in the background. So, thank you everyone who tuned in today, and thank you everyone who watches on the YouTube archive, which is available at risky.tv. And you can follow me on Twitter at HMN_risky to get updates about the series. Thank you also to everyone who supports me on Patreon. That makes the series possible. And I believe I have a new shout out to give. So let me see here. Yes, thank you to Kellen. I think I've mentioned Kellen on the series before. He's a friend of mine. And he has pledged support to the series. So thank you again, Kellen. That is very nice of you. If anyone else would like to support this series, you can do so at patreon.risky.tv. I will see you in the next episode, and stay risky, everyone.